Okay, all right, cool. Thank you very much for being here today. My name is Ameen Altajer. Um, we're actually live, so we may start. Yeah, so the name of the talk today is going to be called Artificial Intelligence, Boosting Business the Right Way. And it's going to be about understanding how AI works and how you can really leverage it when it comes to the business. If you're a business manager, if you are somebody who's just interested in knowing how artificial intelligence works, have to use it uh, within business or even within any social, let's say, case that you guys work on. Okay, so let me just share my content in here. See, okay, perfect. So I think you can see my screen here. Perfect. Okay, so again, just for the people who just joined in, my name is Ameen Altajer, and this talk is going to be about artificial intelligence. We're going to be talking about how to boost business the right way with, artificial intelligence, basically. Okay, let me just add another feed here so you can see both of us here instead of just me, showing the screen. Awesome. Okay, so now you can get a glimpse of me, and at the same time you can see the content. Perfect. So let's just go forward. So a bit about myself. My name is Ameen Altajer. You can, get a hold of me on ameenaltajer.com, or you can just, contact me on Twitter or Instagram at Ameen Altajer. We also have a business named INFINITEWARE. We do a lot of work in artificial intelligence, as you will probably see in a bit. And there's a lot of products and services that we have to span the AI space. So there's a lot to it, and it's just, it's a wonderful space, honestly, to be in. And I'm very fortunate to be here today to share my experience and the way we do things here in INFINITEWARE, and we leverage artificial intelligence to making value to a lot of people. Okay, all right. So a bit of our clients, we've got Saudi Aramco, SDC, Zain, the government, Mr. Interior, a lot of people out there. I don't want to, bombard you with, the business news and the PR here, but, just for you to understand where we're coming from. So in INFINITEWARE, we believe in three values. The first one is we automate mundane or repetitive work. As somebody who worked in the corporate industry for a very long time, I can definitely vouch that there's a lot of work that has been, there's a lot of work that is being done in a very repetitive fashion, in a very manual way. And so my goal, when I started INFINITEWARE, was to actually create a sort of framework that can take all of this mundane or repetitive work and just automate it all the way, allowing us as human beings to go and focus more on what really matters to us. Other than that, we promise more intellectual bandwidth, meaning when we take care of those tasks that are mundane and just repetitive, you get to have more intellectual bandwidth to focus on what really matters to you. And last but not least, really care about intelligence to make value, which is really, really important for us here. So we believe big time in the idea of intelligence and leveraging it really within any cause that you guys have, be it a business, be it a social cause. Nonetheless, using intelligence is really key to being at the forefront here in this world, in this era. Okay, so this is enough, enough about business and such. Let's just get, and just dive in within the content in here. So the topic today here is going to span four major chapters. The first one is going to be called Hype Teardown and a look under the hood, which basically means that we're going to just understand what AI is, trying to just, roam around within the hype, understand what is really true about artificial intelligence, what's super fake about, artificial intelligence in the news, as it is really important for us to understand and really just have a middle ground with our expectations. The second chapter is going to be called Real Use Cases and Applications, which is self-explanatory. So the idea is we want to understand the real use cases of artificial intelligence and the applications, from, again, from the flood that we keep getting on social media, on LinkedIn specifically, as there's a lot of stuff happening in there. We can't tell, if some use cases are really valid and if they're actually applicable, be it in the business or any other place. But to really understand what AI is capable of and what it's not capable of is really key to, dealing with the media. Thirdly, we're going to be talking about a manifesto to effectively, create a pipeline, an AI pipeline, digitally supported pipeline, be it in the business again, most likely in the business. Last but not least, we're going to be talking about the laws and the challenges and the risks risks accompanied in adopting artificial intelligence. So, as you can probably tell, we have a long journey, and we're going to be talking about four major poles here in the subject here today, which are really key to making really good use of AI. Okay, so starting with the first chapter, I tear down what's happening out there. Let's get to it. First things first, let's just try to break down the whole definition first. So everyone keeps hearing about artificial intelligence, and there's a lot of, let's say, confusion when it comes to understanding the actual gist of artificial intelligence. So I figured out that I just clear it by the definition first, and then we can dive in, with the real meat here in the talk today. So if you go to Wikipedia or any of those major encyclopedias, and you pick up the definition for artificial intelligence, the first thing that they're going to tell you is probably something like that. They're going to tell you that artificial intelligence is all about artificially depicting cognitive skills and learning, problem solving, most of the time mimicking human intelligence. So here's the thing. With artificial intelligence, the idea is that we're trying so bad in order to give that sense of intelligence and giving it to the machine. So we as human beings, we believe that we are the best kind when it comes to depicting intelligence, believe it or not. And so for us, it's a huge mission to go and put the same intelligence feel in a machine. And that can really span a lot of skills. That could be the idea of learning, the idea of problem solving, that a lot of people just use easily, but have very huge difficulty trying to understand how it works from the inside, correct? And so what we want to do here is we want to understand what artificial intelligence, and it's just basically two things in the modern era here, is that you have cognitive skills that span learning, and learning, again, by the way, is a very difficult skill to teach to the machine. However, we just easily throw it every now and then. And the second thing, you want to have this sense of problem solving, and you want to give it to the machine. Most of the time, mimicking human intelligence. Okay, now to understand how things work and how things have changed across the years, let's start with the traditional programming model. Now, back in the day, if you wanted to build a system, what happens is you get to have an input. In this case, you go and work with a BA, or what we normally call business analyst, and then these guys come up with the specs, with the specifications of building a system. So imagine you're trying to build a system for the airport, for the sake of example. So with the input, what you normally do, sorry, you go and ask the business intelligence, the business analyst guy, to get you all the requirements needed to build that system and have them in a written format. And by having them in a written format, you normally have this tangible medium that you can then give to a developer, and you can ask them that, okay, so here's my requirements. I need them in a tangible, executable format, meaning just create a program for me out of those requirements. Yeah, and then the output is there. You get the output. Now, this programming model has been there for a very long time. It is functioning. It is doing a great job. However, there are issues with that sort of model. The first thing is we are heavily dependent on the business analyst in this case. So if you're, let's say in this case, your guy does not really know how to exactly write the requirements that they have in mind, there's a huge chance that the programmer is not going to do a good job by implementing wrong things, right? And the other aspect is, even if you have a brilliant BA, brilliant business analyst, there's a huge chance that the programmer is not really that qualified, which means they're going to have a very rough patch trying to build a system that does exactly what you want. So this is for the first case. Now, what happened here with machine learning is that the whole paradigm now is shifted. You didn't just get to have a program written for you by somebody. What you do, what you basically need to provide for to have this sort of sense of artificial intelligence feel is that you have this unique and generic algorithm. All right, so we normally call this machine learning algorithms. Again, just remember, it's a unified algorithm, meaning you can use it in many ways, in many fashions. And then what you have to do is you just provide the input, and you provide the desired output, and you go on and on and on by teaching the machine until you get to that stage where the program is written for you dynamically, which is really beautiful. So to think about it, you don't actually go and write the exact requirements. Even if you're not sure of what you want to accomplish in terms of requirements, What you have to provide is just the input, and you provide the desired output, and then you get the program written for you. Now we're going to see examples like that, but just remember that the paradigm has tremendously shifted from the older traditional programming model until this, the new machine learning model, where you just provide the input and you get the output that you want, and you don't care how the code is written. It's going to be done by you, the machine for you. Yeah. Now it's really fair to say that machine learning, in artificial intelligence are actually, have always been there, by the way, and it has multiple, let's say, generations. We've got multiple generations for the tech until we got to the stage where we have something that we call deep learning. Now with deep learning, in order to get all of these great results that you've been witnessing online, what we've done as a humanity is that we've based a lot of our work actually on how the human brain works. So if you ask a neuroscientist and you tell them, can you tell me about the human mind? They're going to tell you that the basic block for building intelligence in the human brain is what we call the neuron, which is the cellular, it's basically the nerve cell that powers the whole human mind. And so machine learning engineers, or let's say in this case, artificial intelligence folks, have been taking a lot of inspiration from the biology of the human brain and trying to reproduce it back again in the machine world. And by using deep learning, we're basically, basing all of our work, majority of it, to be frank, on human biology in order to get that to work. Just for you to understand how things work in terms of scale. So artificial intelligence is this big circle. We've got a lot of stuff happening inside, this sort of circle, artificial intelligence. You've got computer vision, you've got natural language processing, a lot of things in there, evolutionary programming. So we've got so many disciplines that go under artificial intelligence, correct? It's not just the regular artificial intelligence stuff that we've been hearing just now. It's been, just to be frank, artificial intelligence goes back to the 50s. So we're talking now maybe 70 years worth of work that is just, this was just there, for a very long time. And then we've got also machine learning. So machine learning is a subset of artificial intelligence, which means it's not a different set. It's part of artificial intelligence. However, it's a subset of it, and it's just concerned with teaching the machine how to learn by itself. So back in the day, whenever we wanted to build a program that we can call intelligent, we actually had to go in and bake the rules. This is what we call GoFi in artificial intelligence, which stands for good old-fashioned artificial intelligence, which means in order to get that sense of artificial intelligence and intelligence, you have to just bake in the rules, write everything in logic in the program itself, and you're trying to conquer every single scenario that comes on board. However, this sort of mentality doesn't really scale, and the problem is there's a constant feedback that humans have to do and put more rules as they come across more rules, and so it doesn't really scale. However, with machine learning, what happens is we're leveraging statistical models, a lot of math here that allows the machine to build a generalized format for what it learns from the data in order to cope with more variables. Now with deep learning, which is another subset of machine learning, just check it out. You've got multiple circles all within each other. So with deep learning, what happens is that we're basing our work on human biology, but again in a machine learning format, hence called deep learning. And so just to give you a bit of the landscape here, again, just to summarize before we move forward, artificial intelligence is this big circle. There's a lot to it. Machine learning is one circle within artificial intelligence that is concerned about giving the machine the sense of learning. And then you've got deep learning, which is basing a lot of its work on human biology in order to go and get that sense of intelligence, basing our work on all the things that we have in the human brain. Okay, a few things to note here, and I probably mentioned that just now, is that AI is not new, okay? No matter what you heard all over the news and everything, AI is not new. It's actually been there since the 50s, as I said. There's a lot of work that has been there and has been done there in the 50s. And we're very fortunate to be here today talking about all these, fruits of such an industry, such a field, acting as if it's just new and we're doing a tremendous job here. But in reality, there's a lot of work that was done for us. And again, I want to ask here, but I'm not sure if I can have the contribution of the users here or the audience in this case. Uh, but there are two main reasons that allowed artificial intelligence to really go big. Yeah. So we had two things that really made artificial intelligence just go crazy, for everyone out there. And in case you can't just go in and participate, I'll let you know. The first one is we've got a tremendous amount of computation power now. You probably heard about the cloud, correct? So what the cloud is doing, it's just basically allowing people to go and offload some of their processing on somebody else's data center. So we've got on behind our Amazon Web Services, we've got Microsoft Azure, we've got also Google Cloud Platform, all really great platforms that allow people to offload their computational requirements on their data centers, which means you as a user, you only have to go and just get a very solid internet connection. And there you have it. You just offload all of your processing there and they can do it there for a very cheap cost, which is really great. Now, I always bring that sort of analogy for people to understand the difference here. But back when I was working in Saudi Aramco, in Saudi, one of the major things that we had to do actually was to offload most of our computation in a cluster that we had to book. So this was not really that pleasant because it means that we had to compete over, the cluster, and whenever we wanted to do a scientific computation, right? Now what happens here is that you have the abundance of the cloud. You no longer have to go and book. The second you have the cache for it, you can just go online with few clicks. You set up the whole thing for yourself. Other than that, we've got a huge repository of historical data. Now this is really important to understand. Machine learning as of today, or in this case deep learning, if you want to be very specific, really depends heavily on the idea of data, which means if you remember from the old paradigm that I just showed you, you have to have input and output in order to get, in order to get to the code that will do the job for you. In order to get to that, you have to have a lot of data. So deep learning is heavily dependent on data. And we human beings have been doing a great job at trying to, get data across the years. So those two things really worked out for us really, really well. And if we dive in now, artificial intelligence has three subdomains, really, really, maybe probably more than that, but the major ones are those three. So you've got supervised learning, and you also have unsupervised learning, and you've got reinforcement learning. So let's just explain each one of those, and give it some time. So supervised learning is a field under deep learning itself, and what it says is that, as you have the examples, as you have the data, and you push it to the machine, and you give it to that unified algorithm, you want to supervise the machine. You want to supervise, the whole exercise. Meaning, imagine I want to tell the difference between cats and dogs, which is a very complicated exercise if you really want to do it in terms of programming. It's a very difficult exercise to write with the code that can tell the difference between cats and dogs, as we have a lot of variety. We have a lot of, let's say, cases out there, and it becomes almost impossible to just write a generic code that can tell the difference between cats and dogs. However, with machine learning, it's a very easy exercise, to go and just build a program that does exactly that. And the way we do this is that we acquire a lot of photos for cats, and we acquire a lot of photos also for dogs. And then we have this generic system, which is very basic, and you just give it an image, and then you tell the machine in a way that, hey, this is a cat. And you do it all over again until you finish, you finish the data set that you have. So you push in a photo and you say, this is a cat, this is a dog. And you go on and on and on and on until you finish your data set. So imagine you have, let's say, 10,000 photos. You're going to be doing that exercise for 10,000 times, yeah, until the machine itself, by looking at those examples, is going to tell the difference between cats and dogs without, asking you to actually write the code for it. And the beautiful thing is, as I told you in the beginning, you don't need to know about the implementation. You just provide the examples, and all of a sudden, this machine learning algorithm is going to tell the difference between those classes that you have, which is really beautiful. The other way is what we call unsupervised learning, which is, I would say, a bit more difficult than supervised learning. And the way this works, in a nutshell, is that you don't supervise the learning aspect itself. Meaning, okay, you have the data, but you don't tell the algorithm that, hey, this is a cat or a dog. You just push the data, and you expect the machine to tell, that there's a structure of some sort, there's a pattern from the data that I just received. So supervised is not really that easy to begin with, in my honest opinion. Reinforcement learning is another scheme of machine learning, or artificial intelligence in this case, which allows people to go in and build a simulator, let's say an agent of some sort. So if you have a game, or if you have a simulator experience, you want that agent to take decisions in real time. So as of today, we'll just focus on supervised learning, as it is the most relevant when we're talking about business. Yeah. Okay, so within supervised learning, remember the supervision-based sort of model here in machine learning, we have two major functionalities that we can use. The first one is called classification. Now, classification, as you can probably tell, is a very simple case of telling the difference between two classes. In this case, we have cats and dogs. So if I have a lot of photos for cats, as you can probably tell here from the left side of my screen, and you have dogs also, what we have to do as engineers in this case, or people who want to have this sort of functionality, is to just acquire the data set itself. So believe it or not, getting the data is probably much more difficult than the exercise itself. So getting the data, cleaning the data, and making sure that the data is ready to be used by our generic AI engine, okay? And then the second you have those photos, you just push it in the system, and you keep informing the machine that this is a cat and this is a dog. And there are multiple ways to actually accomplish that, either by having an Excel sheet where you have every single row that contains the link to the image, the actual class of the image, and when you feed that sort of Excel to the machine, it will be able to load all of the photos. And it's going to sound like as if you have a kid, right? So your kid is actually looking at those images, and then by showing that kid multiple examples, they'll be able to tell the difference between cats and dogs. You don't need to tell them that a cat has whiskers, for the sake of example, or a dog has this, let's say, this different shape for the face. It's just a matter of showing examples and then, relying on their guts or common sense to go and tell the difference between, the two classes. So this is a very major functionality within machine learning. And by the way, if you're interested in getting data sets, as I told you here, it's one of the most difficult ways to handle such a thing. We have a website here, is a very popular website. It's called Kaggle.com. And Kaggle was actually bought by Google because it's so important. And from Kaggle.com, you can go in there and you can actually write for the different data sets that you want to acquire, be it genetic data, cats and dogs, games, let's say criminal records. So there's a lot of, like, a huge variety of data sets that you can work with if you want to build an AI system, or in this case, specifically talking about machine learning based systems. So this is a good example. Now, when we're dealing with photos, it doesn't mean that we only have to deal with cats and dogs or just photos or faces and such. We can also work with financial data. Now, a very important and a very common use case in the financial industry is detecting fraudulent transactions, which is a very difficult job, to be quite honest. And the way we do this, and to be more exact, the way banks do this, is that because they're sitting on a goldmine of data, because they have a tremendous amount of data that they can work with, it's just very easy for them to feed that sort of data into the AI generic engine and then tell it that this is a fraudulent transaction. This is not a fraudulent transaction. This is a legitimate transaction. And this goes on and on and on because a bank is probably sitting on a goldmine of data. They have a tremendous amount of data that they can work with. And by showing this sort of data set to an AI agent, or sorry, in this case, the AI engine, it'll be able to tell the difference between legitimate transactions and fraudulent ones as well. So this is a very good example of using the same classification machinery and artificial intelligence, but not just for photos, even for things that resemble other data. It's fair to say here, one point that I want to mention, that every data that you have, every data bit, is actually scattered into two things. The first one is what we call features, and the other aspect is what we call label. So label is the thing that you're trying to get. It's the ultimate result that you're trying to predict. In this case, is this a legitimate transaction? Is this a fraudulent transaction? So the mere idea of legitimacy here, fraudulent, not fraudulent, is what we call the label, which is normally noted as a specific column in your Excel sheet, if we're just talking about Excel for the sake of example here. However, features are the specific components that give data its uniqueness. In this case, let's talk about the first row here for the sake of example. Every bit here, every column resembles a vector, resemble a feature. So you've got transaction date, post date, the type of the transaction, description, expense category, and the amount. So all of these things, the sum of those things are, so we have 6 columns in here, and these 6 columns resemble the features of that data for that specific transaction in here, the first one. And then by having another column that we call class, or in this case, a label, we're telling the machine we want you to predict this sort of from that data. Can you really tell if this is a fraudulent transaction or not? So here's one thing to think about this. Just commending all the other points here again, the photo itself is the feature, and then the label, in this case, cats or dogs, is the actual label. Yeah, perfect. So understanding classes is one way of dealing with machine learning in a supervised learning fashion. But we also have what we call a regression. Now, regression is the other aspect of machine learning in a supervised learning. So the idea with the regression is that you just don't pick classes, just like with our examples, fraudulent, not fraudulent, cat or dog. With regression, you're trying to predict a continuous amount of a number from a continuous sort of line. So imagine I get you, so a good example of that, just for you to understand the point here. In Bahrain, we normally rely on people who understand how assets are being priced in order to buy, let's say, a real estate property, be it a land or a house. And so we're depending on these people's experience in order to tell us that this house is probably is worth 140K, or this house is probably worth 110K. Yeah. And so what we do normally in machine learning is we do the exact same thing. However, we're not asking for a specific class here. Is this legitimate or not legitimate? We're just telling the machine, can you predict the number? Can you predict the price of that property? And we've been doing this personally here in INFINITEWARE. We've been doing this for a very long time for our customers in the UK. So it's very easy for us to depend on their data set, especially if they are, they've been working with real estate for a very long time. And it's just a matter of, putting that data set in an engine, yeah, and then we tell the machine we want you to predict the prices, and that's pretty much it. So this is for the housing prices. And it is really worth to mention here that Google, is doing a context-aware search, just like what we showed there in the past, but Google is doing it in a different fashion, meaning everything that you write in the search bar actually gets you results that are relevant to yourself. A good experiment that you can do is when you can search for something and you compare your results with let's say your friend or a colleague, you're gonna see that the results that you have are completely different from what your friend is getting. Maybe the order is different. Maybe the stuff that you get in the top list are much more relevant to your field, to your search preference. But all in all, we're not getting the same results, which is a very important point here, just to figure out this point here. Okay, so this is pretty much what artificial intelligence is, just for you to understand a bit of the idea here. Let's talk about some of the applications that we can power up our systems with. When we're talking about customer-centric experiences, we've got many things that we can do. The first one is what I call automatic personalization. Now, how many of us have really gotten, let's say, SMS messages from banks or other, organizations trying to pressure us to buy something? And most of the time, you would get that message and it wouldn't seem to make sense because, imagine you're a young kid and you get a message about getting a mortgage to build a house, or let's say a mortgage to buy a house. In this case, it doesn't really make much sense because you're not the target class for that sort of advertising, correct? And so the problem with that design is, most companies rely on mass advertisement, this sort of mass, this SMS sending thing that a lot of people rely on in order to get, to the maximum amount of people, potential people to buy the service or the business. And this doesn't really work well across the years, it's just too difficult to target a specific criteria and get to them directly. Now, what people can normally do when they're dealing with artificial intelligence is that they can rely on automatic personalization, meaning because such businesses like banks and the other ones have a lot of data about you as a customer. Like if we're talking about a bank or banks in this case, every time you swipe your card, it's very likely that you are going to get, you're going to send your merchant details to the bank, and they will probably know the amount that you spent in there. So it's very easy for them to tell that this guy is somebody who is a big fan of coffee, for the sake of example, right? Or this guy loves, this guy wants to somehow, let's say here. So what I'm trying to say here is that many people can really benefit from, really, getting the data that we have and building something, that is really valuable for the customer. You can give them different experiences. And so what we normally want to do here is that we want to leverage the data that we have to build a different experience, a different target for every one of those people here. Yeah. Okay. The second thing that I want to talk about is that a lot of people now are relying on, chatbots in order to do things, right? So with what we want to do here is that we can build a chatbot system that really understands your data and what you normally do in order to present you with something really valuable. So a lot of telcos now are currently relying on specific chatbots in order to get things to service them really, really fast. And the best way we can do that is by relying on, on the data to give them what they want. So imagine you're going to your service, and instead of you wanting to, to actually roam through the website in order to get what you want, you can easily just write it down in an English-like format and get the answers straight away, which is really, really cool. And so with the chatbot, which relies heavily on natural language processing, in order to get you the results, is a very great way for people to go and get you results that are really valuable. Yes. And so this is one way of dealing with chatbots. In case you did not know about it, there's a new breakthrough in the world of artificial intelligence, especially a thing that we call GPT-3. So GPT-3 is this sort of machinery, yes, this sort of machinery that was done by a company called OpenAI. And the idea is that with GPT-3, it understands language. It's very easy for us to just write what we want in terms of English, and the machinery itself is going to understand what you want. Yes? So artificial intelligence is really, 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 really great when it comes to understanding, language and sentiment and the actual meaning of your sentences in this case. So GPT-3 is a great deal. You got to check it out. The application can even write English on your behalf if you want. And so let's talk about internal efficiency and performance for some companies. Yes. So sentiment analysis, the thing that I kept talking about, can really, really, really benefit out of artificial intelligence. And so back in the day, whenever you wanted to get an output of somebody, what you normally have to do is you give them this sort of box that we call the feedback box, and you ask people to go and put their comments, all of their details in there, and so we can read the feedback and really enhance your services and products. However, this is not really a good method, doesn't really scale, to be quite honest. So with sentiment analysis with artificial intelligence, things are becoming completely different. So a good example is a lot of people rely on Twitter to put their thoughts, to put their comments, to put everything that they have in their mind, for such a thing. And so we as businesses can really leverage the idea of artificial intelligence to understand the meaning or the value of those tweets to build good input. So imagine you have a new product hitting look, you have a new product and other stuff here as well. And so what you do is you can just pick up a specific hashtag in Twitter, and you can ask it to just get you from Twitter all the data that belongs to a specific tag, which is really, really easy to do if you are a programmer. So it's just easy to go to Twitter and you say, you know what, I'm just gonna listen to that hashtag and get every single tweet that belongs to that hashtag. It's just so easy. Yeah. And then using machine learning, things like GPT-3, the things that we talked about and such, we can read the content of the tweet, understand its value, and then really classify it if this is a good review of my product, this is a horrible negative review of my product, and such a thing. So you can build that automatic machinery right out of your data. So it's so easy to do that. Okay. And not only that, now with machine learning, even for customer service, things are completely changing. A good example is when you want to monitor the customer service, let's imagine call centers or such. It's just so easy to pick up those calls and pick up the tone of the the people who are talking, and understand if they are being if they're frustrated out of the call, or even from their facial gestures. You can really tell if somebody's having a good day, if they're having a very bad day. There is just too much information that you can get. Okay, so Noor is asking, can we get the slides? Yes, I'll publish them later on. You can actually check them out on my website. It's going to be ameenaltajer.com, or you can just check out my blog, which is ameen.ai. I'm going to post it there. You're going to have a lot of information later going forward, okay? Okay. So yeah, so this is for customer service. Let's talk about other things. Just what I said here, just to recap on the subject, getting those visual details, getting those auditory details also from the call center is now it's easy matter. It's not as difficult as it used to be before. And so a good example that I want to show you here, so this is an example that I got from Microsoft. So Microsoft Azure has this sort of service that allows people to go and upload images, and it's going to give you a lot of details on the image itself. So I have uploaded my image here on Microsoft Azure, and it can tell you that I wear glasses. If I, in this case, I don't have lip makeup or eye makeup, which is really good. How I feel in terms of emotions, the gender and the age. It's really so cool to have that sort of accurate data, for that sort of thing. And remember, this is not just a website that you can leverage on. These are APIs or functionalities that you can bake in within your programs, which is really, really cool. So depending on your maturity on your products, you can leverage those things and you can put them in your code in your application. Yes. GPT also, one of the great things that it does, it can even write code on your behalf. So a good example is, you can check it out online. It's so easy to write your commands in English, and then it will paste, or it will write, in this case, the specific technical terms and commands for you. So we got to this stage now within artificial intelligence because it understands language so well. We can build a system that reads our content in English and can spit out, the things that we want to do, for example, in command line or other systems. So this is really beautiful. You have to check it out. Another example also that we can leverage in our systems or in our businesses is the ability to scan a document, and then from that document we can extract the text, and not only that, make sense out of that text. And I can tell you from experience that Temkeen, for the sake of example, is basing a lot of their work on this OCR functionality, and it's just beautiful that it can pick up those stuff and can populate multiple things in their internal ERP system without the hassle of manual input and such. So yeah, just think about that. And when we're talking about artificial intelligence, we also have new business models that we can explore. So a good example is open banking. Now, open banking is this idea of having an API interface. So API is just another term or a synonym for a formal gateway, a technical gateway to a system. And this allows us to go and extract data from those banks and feed it as into our system. So a good example is you can now build business models as a startup, of course, or even another company and mine can really benefit from those APIs that are currently being opened by those banks, forced by the regulator, in case you did not know, and we can build use cases and tools, that can add value to our customers. So this is really, really great. Let's think about that for a second. So one of the use cases that I really, really like is that, by having access to open banking, and by the way, I have another talk on open banking. If you guys want, you can check it out on YouTube for the crowd of Google that I've done probably in the last 3 months. But the idea here is that with open banking, you can have really tremendous amount of use cases that are valuable. One of them is we can correlate habits and spending. So imagine you don't have control over the way you spend money. And so what you want to do is you want to have this sort of system that can tell that maybe it's not the right time to go now and buy dinner from the outside, or maybe you want to cut some some spendings when it comes to going to the cinema or such. So all these financial sort of so this sort of advisory can be done also using machine learning, because it has access to your data. It knows the way you work, the way you spend your money and your habits. So very easy to implement. And a lot of companies now that have a lot of data are exploring new sort of paradigms now of building their products and services on top of their data by providing intelligence as a service, which means you don't just go ahead and outsource the data to the outside. You can now also build a very nice API that makes a good use case of your data, and then allow people to go and use this API. A good example of that is Talabat, for the sake of example. So what Talabat is doing currently is it's going because it has so much data. It has so much data on your habits when it comes to food and such. And so the way it does that is because they built a lot of dashboarding and machine learning and such, they can export those functionalities as APIs to their corporate customers, going forward. So your customer might not really be interested in the data itself, but they want to have access to an API that can get them this sort of, really valuable insights. Yeah. So this is what Talabat is doing, of course. Other than that, let's talk about the best way to build an AI pipeline, integrating with the business and building things relevant to the business of AI, and really to think about the best way to go and put that thing in your business. Let's talk about adoption first. So when we're talking about artificial intelligence, adoption is a pretty big deal, which means it's not always the best thing to do is to just add artificial intelligence. It might be that it is not really worth it to add artificial intelligence after all, because maybe you get to, maybe you think that artificial intelligence is the holy grail of technologies, but honestly it has its own pros and cons. And so choosing wisely is a very important thing. And remember, AI is not a silver bullet, which means sometimes it works, sometimes it doesn't work. Yes. And the other aspect is everything is available and cheap, which means imagine you want to build an AI system. It's very important for you that you don't just build everything from scratch. You can build things, on top of people's from the people's work. And so I'm going to show you multiple tools and services that you can leverage your work on. But remember, don't build things from scratch most of the time, unless you really want to be so slow when it comes to getting to market. So you've got two ways when it comes to adding AI to the business or in your cause. You can either get a ready-made tool and try things out the quick and dirty way, yeah, and I'm going to show you some of those things, or you can build a manual pipeline that involves machine learning, acquiring data, training the AI algorithms and such. So there's a lot of work that we can put in here. The first thing that I want to talk about when we're talking about ready-made stuff is the idea of this tool that we call robotic process automation. So RPAs are becoming super popular, and the idea is you just have this sort of drag and drop environment where you can just put things, drag and drop, and you build a functionality. It's just very easy to do that. And I'm going to give you an example. So this is a very popular system. It's called UiPath, a very, very popular system. And the way we do this is that we can just drag and drop about Sure. It's just one thing, which means imagine it has, so this application UiPath, it has this integration with Outlook, and it allows people to go in and build, automated systems using just regular RPAs. Yes, it's very easy to deal with. So if you don't want to put a lot of effort, you can do that. It's very easy. And other than that, the open source community is really, really generous, which means when you want to do work, most of the time you don't want to just do it from scratch. You just want to do things that are, based on other people's work. So we've got Linux, we've got MongoDB, we've got Git, so many tools out there that are powering this. And the same thing is also true for machine learning and artificial intelligence. So with artificial intelligence, we've got tools that span TensorFlow, we've got PyTorch, we've got NumPy, OpenCV, Keras, Caffe2, so many tools that are just outsourced out there that allow people to go ahead and build machine learning models, in this case, machine learning programs, with little to no effort, honestly. So a good example is Keras. So with Keras, you can build a machine learning algorithm that doesn't take even more than 8 lines to build a simple functionality for a few apps. So it's really, really wonderful. Now, if we're talking about a typical pipeline for machine learning, in case you want to do things from scratch, I would advise the following. So imagine you don't want to use RPAs, you want to build from scratch. The first thing that you want to do is build this sort of machine learning pipeline that is going to be intensive in ways. The first thing out of that pipeline is going to be grabbing the data. So we have many tools that are on Google Cloud Platform, HDFS, Cassandra, and other systems that allow you to get the data from multiple sources. Imagine you have most of your data in Excel or in your MySQL databases or such, and you're just trying to get all of this information and get it and harvest it before you can build an AI system. Other than that, we have tools like Jupyter Hub or Jupyter Notebook in this case. You've got Spark, and those tools allow us to consume that data and actually clean it and work with it. And then the gist of the exercise is with tools like TensorFlow. So TensorFlow, similar to PyTorch, are systems that allow us to go ahead and train the AI model. Remember when I talked about cats and dogs supervising that sort of practice? This is the case. So with TensorFlow, you use all the data that you got from the first stage and the second stage, and you somehow inform this generic AI system that we need to do this, we need to do that, this is the cat, this is the dog, and you go on and on and on and on. And by the end of it, you have what we call the model. So the model is your ultimate deliverable, the thing that you're going to eventually use. Last but not least, you want to deploy it. So we've got multiple ways that we can deploy an AI system. You can either deploy, for the sake of example, on the cloud, which is a very common practice. If you're coming from a GCP environment, Google Cloud Platform, or if you're coming from a Amazon Web Services, and the other cloud services as well. But you can also deploy on mobile phones, for the sake of example. You can also put all of your AI work on the phone itself, on the watch here, and without needing internet connection, which is really, really good for some use cases where you have to do AI work without depending on the internet. And when we're talking about BI, which is very relevant to artificial intelligence, so BI is business intelligence, they go hand in hand. So with BI, you need to have this sort of dashboarding tool where you get information about what's happening in there. You've got Power BI, you've got Alteryx, you've got Tableau, really, really big tools in the industry that allows you to go and build systems. I want to also talk about cloud providers. So when we're talking about the cloud here, you've got so many functionalities. It's not just having machines in different data centers. You can also have baked-in functionalities. Remember the example that I showed you from Microsoft Azure, where I just uploaded my face and I got so many information about that thing? Well, that sort of functionality is available on Microsoft Azure because they want to spare people the headache of building machine learning models from scratch. Acquiring data, doing all that work might not be your cup of tea. You might want to do it when you want to have something super custom. But for generic stuff, you can always rely on Microsoft Azure, GCP, and AWS to build AI functionalities that that are just let's say quick and dirty without really needing to go and build something super custom. So remember, Cloud is your friend. You can do so much work on the cloud without going forward and needing to do things from scratch. The skill sets of the modern world. I want to get you a sort of a glimpse of what you need to, put on your team in terms of qualifications in order to get, the best of machine learning. The first thing is data scientists are very important. So data scientists are the people who are concerned with the data. They understand the data, how to clean it, how to get the best of it. And then you got machine learning or AI engineers in this case. These people are going to be tinkering with those tools. TensorFlow, PyTorch, they're going to build the AI agent by taking the data and pushing into the system. So those two people here, those two kinds are very key when it comes to building, an important machine learning model. So just think about that for a second. Other than that, you've got DevOps engineers. So DevOps is becoming super, super hot currently. A lot of people are focusing on machine learning. And other than that, data protection professionals also. So data protection and laws are also disciplines that are becoming super, super crucial now, given that we are dealing with tremendous amounts of data and we can't make any mistake when we're dealing with data also here. And so when I want to summarize, in order for you to get the best of artificial intelligence, remember 4 things to work with. Sorry. You need to invest in good data, in good people who can handle the data itself. There's no way around that. It's just very crucial to have clean data and people who can work with it. One concern that a lot of people have, and it's really worthy to share here, is that not every data bit is really worthy of using in machine learning models, machine learning systems. Some data is not clean. Some data are just purely wrong. And so we have a saying in computer science, which is garbage in, garbage out, which means if you don't base your work on good data, you're going to be in a very difficult spot. So just think about that for a second. And second thing was we have, you got to really know what you want to accomplish at the end of the day. Remember, AI is not a silver bullet. It's not going to solve all of your issues. In fact, there are cases with artificial intelligence, it is really the worst choice possible. It's the worst choice that can ever go with when you're building a system. It's very easy to go with a very typical easy system, instead of going with that sort of thing. And so always remember and ask yourself, what is the problem that I have? Is it worth it to solve it with artificial intelligence? Not the other way around. Don't just say, I have artificial intelligence, how can I use it? It doesn't work that way. Third, utilize the existing tools and infrastructure available and never reinvent the wheel, unless you're just doing it for fun. Otherwise, they're going to be lost in the race here. You're going to lose the race. You're going to lose the race because the market is just too fast. There's a lot of changes, especially in the AI field. And with you using existing technologies, you have a better chance of reaching the market faster than the other competitors that you have. Other than this, start with a small proof of concept. Don't go for really big projects. Work with something really small, mostly in automation, just to make sure that everything is okay. Yes, and yeah, that's pretty much it for building the perfect let's say building platform for artificial intelligence. Let me just talk about the risks and the attention points before we close the session here. And the first thing that I want to talk about here, there are problems that are inherited with artificial intelligence. Not everything is pink with artificial intelligence, as we said. The first one is it is very data hungry. So all of these examples that you guys seen now, from cats and dogs, financial data and such, they rely big time on data. You have to have a huge amount of data in order to get to those results. We're talking thousands of records, thousands of bits of data. So it might not be always easy to go ahead and acquire the data. It might seem easy, but in reality, getting that tremendous amount of data is sometimes very difficult. We also have companies that specialize in that sort of thing. Also, the neural networks, or in this case, the machine learning models that we have, eventually resemble a mystery black box, which means they can get the results. However, it's very difficult for us to go and explain what's happening under the hood. Okay, it's very difficult for us to understand how it works, how they do their magic. Eventually, they're going to get you the results that you want, but you can't use them in every context. A good example is, imagine you have something that you want to use in the justice system, it's very difficult to add machine learning in there, because if you can't really tell, if somebody is criminal and why they are criminal, why they're being classified as criminals, I mean, it's very difficult for us to use it in a production-like environment where we have to go and justify our choices. And so most of the time, neural networks are a mystery black box, which is not easy to work with. Other than that, training, or the practice of showing use cases to the machine, it's very difficult and it takes a lot of time. And so training, this sort of exercise, takes a lot of time. In fact, Netflix and those big companies take up to 2 weeks or even 1 week in order for people to go ahead and do that sort of practice of enhancing their system. So it takes a lot of time. It's not a slow process. Yes, and not only that, artificial intelligence, among the other things that we have, like blockchain, smart and IoT, and big data, autonomous, everything else is susceptible to hacks. So even artificial intelligence itself is also susceptible to hacking events. And in case you want to know about that, I've done a talk for BIDEC, which is the artificial intelligence. So I had a talk relevant to artificial intelligence for the defense conference that happened last year, and you can actually find my slides online if you check them out. You can just write Ameen Altajer BIDEC, BIDEC, and you're gonna find some of my slides where it shows you how you can really trick an AI system to classify yourself as somebody else if you want to. And other than those inherited issues within artificial intelligence, you also have things that have to do with data. So you've got ethical issues in acquiring data. You've got, so a lot of customers base their work on, data that they acquired from their customers, and sometimes just getting this data bits is not the best choice. It's forbidden and sometimes has ethical issues, and so we really have to think about the way we acquire the data and how ethical it is to go about it. You probably heard about GDPR. So GDPR is very popular, and GDPR has a lot of effect on the Middle East as well. So if you have a company that has work in the Middle East and they're dealing with Europe, they will most likely be GDPR compliant. And then Bahrain, we have our very specialized also law and data, which is called BDPL, Bahrain Data Protection Law, which also states in a very formal way how to deal with data in Bahrain, the things that you are allowed to do, the things that you are not allowed to do. So it's a lot of talk and discussions in that area. Last but not least, apart from all the issues that we discussed in the technology and in terms of laws and legalities, also we have the technical issues. So we have scalability. So building machine learning models is not an easy job. Allowing it to scale for many people and to be used by thousands requires different skills. Integration with the regular systems. Imagine you want to bring AI within your bank, might not be an easy thing. Also privacy, bias is a pretty big deal, which means if you base your work on data sets that are biased towards one thing, it might not be an easy thing to do. Security also, security is a pretty big deal. Cyber wars are becoming the new hot things. So you've got so many technical challenges that span the adoption of artificial intelligence. You need really qualified technical people, credible people. Last but not least, I just want to say the thing that I always say to my clients here. In the race of business, data can either make or break your business. Just remember that. And if you're interested in some of my other talks, you can also check out google.com, YouTube, and just write Ameen Altajer in English and Arabic. You're going to find, tremendous talks on open banking and reverse engineering, building game development tools. So you've got a variety of things. I do normally conquer so many things if you're interested. And if you want to contact me, you got to just contact me on my website, ameenaltajer.com. I'm also available on LinkedIn, on Twitter, Instagram. I normally respond really fast. And if you're interested in our products and services, make sure you check out INFINITEWARE.com. So that's all I have to share here today. I hope you really enjoyed it. I wanted to make this really quick, so 15 minutes, just to make sure we cover every single thing. Thank you very much for being here today. I hope you really enjoyed it. And I'm just gonna write my website in here. in case you guys are interested in just a second. Yeah, so you got it here, ameenaltajer.com. It has all of our work, my portfolio, and you can also check out our products and services here. Thank you very much, and you can probably contact me after this on my social channels. Have a good day, and I'll see you soon. Bye-bye.